go. Okay, this lesson is to help you with the circuit diagrams worksheet. Okay, we're starting with page 312 in your textbook. Okay, and I'm showing you some devices. Okay, first of all, okay, what is this? A switch. This is an electrical device that allows electrons to flow and blocks them. Okay, what is this? Also a switch, but like a science experiment switch. Okay, those open and close. Okay, if it's open, would our light or motor be on or off? If it's open, it would be off. Okay, it needs to be connected for the current to flow. Okay, this has a V on it, and it's a measurement tool. What do you think it might be called?
Voltmeter.
A voltmeter. Excellent. These kids are so smart. Okay, and this is a multimeter. It measures more than just volts. It does have settings for volts. It also has A. A is probably for amps. So it would be called an amp meter. Yeah, so ammeter. Okay, it also has something called ohms. O-H-M-S. Okay, so it would also be called an ohms meter. Yeah, ohm meter. Okay, so this is a multimeter. It has ohms, volts, and amps. Volts, amps. Okay, and this is a digital one. All right. What do normal people, okay, that are not in science class, call these? Good guess. They're very small. Light bulbs. Okay, in science circuit lesson class, we're going to call them lamps. Good job. Okay. What are these? Okay, what are these? Wires, and specifically alligator clips. Okay, we're going to use those for our experiments right now. No, close to Christmas. We'll do the fun worksheet and learning stuff first, and we'll save the experiments and labs and projects for close to Christmas. Okay, so that's what those are. And what does it do? Conductor, yeah, converts electricity from, or carries electricity from one area to the other. So on your symbols, on page 12, we have symbols for those kinds of things. Okay, what is this one?
Voltmeter.
Voltmeter. You can talk a little louder. Okay, what is this? Ammeter. What is this, do you think?
Lamp.
A lamp. And in old-fashioned worksheets, okay, and sometimes PATs, sometimes they'll show it as an X. Okay? What else do we have? We have something called a fuse. It's a little squiggle like this. Okay? And its job is to melt. Okay? When there's too much energy going through, and it melts so it doesn't burn your house down. Okay? It blocks the flow of electrons, period. Okay? That's a fuse. Okay? We had switch. Hey, tell me please, is this one an open switch or a closed switch?
Open.
Open. So will my equipment be on or off? Off. So this one then is open or closed?
Closed.
Closed. Okay, if I do this,
Open.
open. It's open now. Okay, which ones did I not list so far? Resistor, and what's this one with the three dots? Motor. Okay, most kids don't learn what a resistor is very well. Okay, so you can be like them and not learn it. Okay, or you could make a special effort to say, oh yeah, that's the one that they never know what that is. Okay, and how you remember is it's something that is variable, so you change. Okay, like the volume knob. Right? That is going to turn it up or turn it down. Like a toaster, same thing, burnt versus not burnt. Right? That is a variable resistor. Maybe you have a dimmer switch in your house where you slide the little plastic thing up and down to make the lights go bright and dark. Okay, those are two different things. Anything else on this list that we did not say so far from page 312? Cells. Yeah, we didn't do the energy source at all. Okay, so regular time in the regular world, okay, we usually call them a battery, but In these lessons, we're only going to call it a battery if we have more than one cell. So you need a short line and a little line. So when you're drawing them, don't make them all the same size and all backwards. Okay, it matters which way they go. So anode, cathode, anode, cathode. Okay, the negative end, the positive end, the negative end, the positive end. So how many cells would be in this battery? 4. Good job. You guys are so fantastic. Okay, so we could leave it there, or we could learn how to actually draw circuits. On your PAT, you will for sure have questions about circuits. Okay, but we don't have to draw them because it's always multiple choice. Same with your unit finals, right? So you just need to be able to analyze them. But I find if you can draw it, you tend to be able to understand them better in the first place. So let's say you have a question and it has a whole bunch of words. Okay, what you need to start with is listing each of the items. Okay, so let's say the question has some information about a 3-cell battery. What's the first thing we're going to list? A 3-cell battery. Okay, so let's do that on the side. There, I have a 3-cell battery. Then and maybe you check it off in your question, or highlight it, or cross it out, or something. Okay, then it says 2 lamps. Okay, and you're trying to remember, what's a lamp again? Oh yeah, that's a light. So you put like 2 times the light bulb. And then maybe it says they're connected in series with a voltmeter. Okay, so whenever you have a series circuit, do we draw what we actually see, which is squiggly lines like this, or do we draw in a nice rectangle? Because engineers and math and science people, they like rulers and calculators, right? So do we draw everything crooked or a nice straight line? Nice straight line. Okay, so we have 4 things, so let's leave a space for 4 things in our series circuit. Technically, you could put them all at the top or side, it doesn't really matter, but we tend to like to put 1 thing on each side. Okay, so it says 2 lamps, let's put 1 here, 1 here, and let's put our voltmeter here, and our 3-cell battery here. There. Okay, so now I've got the question, if this was a series circuit, right? So when we talk about series and parallel circuits, we always get out Christmas lights. Okay, back in the olden days when I was a kid, we had really hot light bulbs. They were called incandescent, and that's how they worked. They got so hot they gave off light in the little filament of tungsten. And they were always like this, in 1 straight line. So is that series or parallel? Series. So if 1 light bulb burnt out, the whole string would quit working. So we had to take 1 light bulb at a time and change it out to see which one was the burnt out one before they would all light up again. Okay, people figured out that there was probably a better way. So now we have much cheaper, what are these called? LEDs. Much cheaper. They're not as bright, not quite as pretty in my opinion, but they save you way more money, and they're not so hot. Okay, and they're connected in parallel. So all these different wires, okay, allow the electrons, allow the electricity, allow the current to flow through to the next one. So even if one of these gets smashed or broken or burned out, okay, then we can still have the rest of the lights working, okay, which is wonderful. Here, Albert Spencer, you can hold on to that for me. Thank you so much. Okay, so let's say the next question adds a motor. Okay, it says add a motor, and the motor is turned off. So you would add a motor in parallel, if it said to put it in parallel. Okay, I always find parallel works like a ladder. You make it look, you know, like a ladder. Okay, but you take those 2 rungs off. And what do I need to make the motor turn off? A switch. Should my switch be open or closed? Open. Okay, so in this case we have a motor that is off. What if I want to turn off the whole thing? Where could I put another switch? Right here or right here? Top or bottom? Top. Okay, this would be known as a master switch. Because if you turn that off, none of these things work. Okay, the electrons can't flow around any circuit. Okay, so starting with that, I would like you to try this worksheet. Okay, this question, this question, this one, this one. The answers are on the section 2 page. And then after that, once we get the hang of it, okay, you will do this page. A little bit more complicated, but that's okay. We're very smart.